Hello and welcome. I'm Bill Wake. We're working on a basic interpreter, BASI, and we're to the point where we've done a lot of work to get our expressions working, and in particular, we've been working on functions lately. So we've got the user-defined functions working, and we've got the framework for system functions. A number of the numeric ones are done, but we're going to finish the rest today. I don't know. This is one of those mechanical kind of tasks I just kind of like to put off. It's like, let's just get it done. Okay, so we'll do that. And then once we finish that, we're going to take a look at subscripts. I think that's the last piece of expressions we need to do, and to handle multidimensional arrays. And with that, we'll have finished, I believe, the whole expression part, and we can move on to more control structures. Alrighty. I don't know where we left things. I think everything's passing. Okay. Expressions. Test predefined numeric expressions. Yeah, that's a good thing. Let's see. Well, we've got a pile of them. We haven't implemented everything. Let's find the list. Yeah, so I left out there. Tests are done. I left out a few of these that are more for printing. So tab, user is something else. Free, we made up a number. Tab, pause, and space are all more for print statements. Yeah, I don't know. We'll see how we want to do that. And then we have, I think we've done maybe len is the only string function. It takes a string argument. Okay, but let's put in some tests. We just want to just get a bare minimum of coverage on these. I think interpreter tests. Yeah. All right, and did I make a check output? You know, we've done a bunch of places where we kind of parameterized our tests or made helper methods for them. Okay, so let's make one for this, and we should have been doing this a lot sooner. Check program results. Okay, and it's going to take one argument that's the program, and then expected output. And it may throw, I guess. No, I don't know if we'll say that. We don't have to with asserts, I guess. Okay. And it's going to look just like this. All right, except we don't need to assign program because we're passing it in. And we don't need to hardcode that. Okay, so this thing basically runs your program, gets the output. Oh, we have to make a program out of it. Okay. Turns it into a program object, runs it, calls the interpreter on it, or passes that to the interpreter, and then calls run to get the output, and then we check it. Okay, so this one should really be check program results with that stuff, and expected output is 8. Okay, if I spell that correctly. Let's make sure this works. And we'll improve a bunch of these first. Okay, so let's use test helper in interpreter tests. We'll push that on the stack, as it were. All right, so everybody can call this. Not everybody, but a bunch of them. Check program results that with expected output being This one's a little different because we're passing in a parse. And we do that a number of times. Okay, but we also do a number where we run this. Okay. Okay. I almost think this would be an improvement. I don't know if I need to do that on this one. How about expecting? All right, let's change that down here. Expecting. Thanks, but that's not really how I wanted to end. Yeah, I definitely liking that better. Results. You can see how we really should have done this a while ago. Let's parse. It's kind of checking the stepping. That's got its own helper. Let's pull the helper function up here with the others. And I don't know if I, leave it folded, what does it look like? Oh, well, let's put this up here. Okay, this is same thing. There were more than I expected. Okay, that one's not. That's not. That one is. These are parses. You might make a case for doing it with a parse too. But in the interest of doing a little bit at a time, we'll just do it this way. Okay, and then the experiment I want to do, I know there's a way to fold this. Is it like... No. Okay. View. Navigate. I don't see any little widgets here that would do it for me. Does that? Oh, maybe I'd right click. Fold. Okay. And let's do the same thing here. Yeah, I don't see it down there. Fold. Okay. So I think of these as lemmas in a proof where you kind of prove a little helper theorem. And I think of these as sort of the same thing, that if you come in here and you understand check program results, maybe you have to open it once and then you can close it again. All right, what I'm curious about is if it retains this for me. Let's close this file, interpreter tests, close it over here, and then open it again. Okay, and it seems like it does. I don't know if I quit and restart, I may not have it, but I like that. I like that better. I want to see the tests, more likely, but those helpers, I only want to open them once, and this sounds intuitive enough to me. 25 print this, get 64. Well, 2 to the 3 to the 2. Left associative in basic, that's the right expected result. Okay. And then these parse ones, we'll do those another time. Maybe I'll leave myself a to-do for that. Use test helper for parse-based tests in interpreter test. Okay. Let's take that. June 1st, rabbit, rabbit, rabbit. Okay. Save that and commit. I guess that's a refactor. Make tests, use helper method. Interpreter tests. And I did not run all my tests, so I better do that. Especially since I edited a bunch of tests, right? Okay. Let's find interpreter tests again. And we're going to check these system functions. Good. All right. Test numeric system functions. And I'm gonna I think I'm going to do them all in a block here. Okay, so let's do check program results. Program is 1 print abs of -1. And expecting 1 new line. Okay, let's make sure that one works, and then we'll do the rest. Good. Arctangent. I know I used this in trigonometry class, X decades ago. Arctangent values. I just want a sample value. And I really don't remember these. Arctangent of 1 equals pi over 4. Well, is there one that comes out nice and even? 0 is 0. That's good. Everything's in... Well, let's do 1 and see if we get something that looks like, 0.8 or so. And these do work in radians. Let's see, 1 gives pi over 4. Okay. We'll take an approximation. Okay, so arctan of 1, I'm just going to guess 0.8. And we'll fill in the actual answer. Okay. 1. Okay, that's a little unexpected. Arctangent of 1 should be pi over 4, right? According to this. 3.14, so half of that is 1.57, and half of that is 0.753. What? Let's check our understanding of arctangent. 1 should be like 0.753. I don't know. And maybe I can give myself a fuzz of that. I certainly don't expect to get a 1 out of arctan of 1. Can I convert double to type string? Arctan. Oh, it's not a fuzz thing. Expression message, floating point, accuracy. I think I can do it that way. 785. I'll accept that. Let's do, so this should work. And this should be similar. Arctan applies a numeric function, returning a numeric result. Let's try float specifically. Just to make sure it's not a float versus double thing. One. I don't understand it. Okay. I guess, let's see. I guess each function that should work. So let's see what's going on here. Let's see. So fn2n. Let's break here. Okay. And we'll run this. The first one we can skip because it's going to be. This should be the absolute value function. So we'll just continue. Okay, so let's print arg sub 0. Number 1. What's okay? Can we print function? Arctan swift.float goes to swift.float. That's what I presume I'm calling here. Okay. Print fn of arg sub 0 dot as float. Argument passed call, it takes no arguments. What is args here? Oh, this is, sorry. We're returning a closure with this thing, so it's not going to be evaluated just yet. Okay, let's step out. Okay, now we can see args. Yeah, ours is our forward closure. Value to value in float to float goes to array of values goes to values. Yeah, I mean, that sounds right to me. We'll step over. I would love if is there a way to get the return value? I'm making this up. Yes, this is exactly the question. You step out, it will work with the source. I can't quite see that window. And action. Well, that doesn't help on the way out. Okay, but this other one sounded promising. Step out, then a return value will appear in the debugger variable view source. What source means there? You'll see a return value in the variables view. Okay. We will try it. Step out. And we'll see a return value in the variables view. Return value equals something. I don't see it. Name ATN. Function.apply. Number float 1. Is that my answer at this point? I'm really puzzled what went wrong. Like, is anybody going to show me the value? Is that the variable view? I think it is. I don't think I got anything here. Yeah, I don't think I'm seeing it in my version of Xcode. Okay, if I go out again, out, okay, step over, what's value? Number 0.785. Well, that's good. Okay. What's going on here then? String.format is not printing it right. %.0f. I don't know my formats enough, but that sounds like I'm asking for 0 things after the floating point. Is that what's going on? Yeah, I think output, it's not so helpful. Okay, I guess we'll continue. All right, maybe I got to look at my formatting instructions. I think we're revealing a bug in our printing. I think the point 0 was, I didn't, when we just have integers, I want them to print with no decimals, but when we have stuff that's not an integer, percent 03D. Yeah. %.4f, number of places after the decimal. Okay, so I'm guessing it rounded it then. Okay. Yeah, so I would say that's a bug in the printing. So let's put in a test around that specifically. Print integer uses no decimals. Check program. If we say 1 print 42, We're expecting 42 new line. Okay. And the other one is test print floating point. Float does use decimals. I don't know if that comes out rounded exactly. We'll see. Print integer uses no decimals. Print float does use decimals. Okay, let's build these. Run this one first. I expect this one to pass. This one I'm not so sure of. Actually, I'm pretty sure it's going to fail. 1. Okay, that's consistent with what we're seeing. All right. Where was that format? It feels like %.0f. No. Well, it's in print somewhere, so let's find print. Okay. So let's see. Yeah, because we used to separate integers from floats at this point, like way early on. And let's see, if I want to say if the number is an integer, I don't know if I have that kind of thing. Dot is integer? No. Okay. Let's say if int, how about if number equals float of int of number? Okay, so if you convert it to an integer, you don't lose anything, and you don't lose any digits, and you convert it back to float. That should be the same number. Okay, and then else, I hate that it loses my position. Yeah. Where's my else? Probably the first error. Switch must be exhaustive. Well. Oh. Okay. Otherwise, I'm going to do this. Return %f number. I should double check my formats, but I'm kind of assuming it's C style. Okay. And let's test this now. All right. Yeah, I really don't want the trailing zeros. Although maybe I should pick one that's more guaranteed to come out even. Right. So it's a sum of powers of 2. If I no. Okay. I don't know. maybe I can find an Apple site one that just explains it directly. I kind of wish the documentation would come up first consistently. I really should have a link. Swift format float. Yeah, this kind of stuff. Okay. At least do that. Floating point. It's really, I mean, the format is the interesting thing. Well, let's try here and then go back and find string. I think format is in here. Yeah. Maybe. Swift format string for float. The thing is, I kind of want a variable. Okay. The Paul Hudson man, he produces such great content all the time. Okay. Point to F floating with 2 points. Okay. Automatically rounds. Yes, that's good. Oh. I could wish for a pointer to documentation, though. Let's try again. Swift string format. String format specifiers. That's what we want. Okay. Yes. Float should be here somewhere. F. Set in a string. Okay. Floats. This is really not the Swift documentation. You can also use $, such as, okay. Let's see this. Right, this is all coming from C. Okay, 0 more flags with modify the meaning. And minimum field width. Padded with spaces. Okay. Precision can be followed by an asterisk or a decimal string. Let's find the asterisk. F. Taken as 6. Okay. I don't need a radix character. Okay, let's find that star. Format can contain n star. field of an asterisk below, described below. Okay, there we go. Indicated by an asterisk. An argument supplies the width. All right, I don't want to spend all day on this. Default is 6 digits. That doesn't feel so far off. Let's see, do we have... I don't know if we have an example that... I have the feeling like it's going to trim off the trailing zeros and just show as much as it needs, but let's see if we can see an example. Surprisingly little in the way of examples here. Oh, here's the USR. Okay, calls one machine language routine, passes one integer value. We're not really going to support that. Okay, that doesn't help any. All right, these are printing integers. So you can see the integers do not have decimal points. Yeah, I think the standard is to not show trailing zeros, but let's add that. We'll make a to-do out of that. I think. Let's see. Format for printing floats. No trailing zeros after decimal point. Okay. But for now, I think let's just document that we're going to print it with 6 decimal places, kind of default standard. I mean, that was kind of out of the IEEE standard, right? Somewhere there. Basic D predates that by about 2 or 3 decades. Gosh, I've got a compiler book. It's compiler construction for digital computers. David Grease. It's from 71, I think. Yeah, 71. I'm very surprised how much was kind of understood and codified even by then. But what struck me was just there was a reference to a paper by Donald Knuth, and the year was 1959. And I think he's still publishing, his art of computer programming. He still releases versions. I don't know how involved he is, but that means he published in the 50s, 60s, 70s, 80s, 90s, 2000s, 2010s, and now 2020s. So he has been touched 8 decades of stuff. Okay, amazing stuff. But yeah, it's gone for quite a while. He was clearly working on compiler stuff pretty early on, and his big claim, I mean, the art of computer programming is just a monumental kind of work, but he developed the LR method first as kind of a theoretical thing, and I believe he published that in 65. And in this book from 71, it's kind of like, well, it's just not, it's not practical. It's more theoretical than practical. But by the time the Dragon book got published, maybe 10 or 15 years later, there were techniques, I think of LALR, look ahead LR, that basically took the giant tables that he had in that LR implies, and finds ways to compress them down, to something that could be embedded in like Yak, and probably I don't know what the more modern ones use, but it's kind of one of those cycles. It's like 15 years from the theory into kind of common practice. Pretty common, but yeah, I was just really shocked to think of this guy's published in 8 different decades. It's like, whoa, amazing. All right. Anyway, this should pass now. Should run and pass. Do we have breakpoints or something? Okay, just slow. This should fail until I fill in the results we expect to see for real. And I wish the debugger would just go find the one that's already in the other window. Okay. What do you think it should be? Well, that number. Okay. And I think, whoops. I'll just leave this documentation here. What the heck? Okay. Now, usually my normal mode is not a bunch of assertions in one test, but when I do these with the helper functions and I've just got this kind of table of stuff, I don't know. I guess I don't need that. In a parameterized test, I would have a table that has inputs and outputs, and the system would iterate through them automatically. With this case, I'm just kind of documenting a bunch of stuff we're already doing, and I'm willing to not kind of follow a range act assert kind of thinking. I'm just documenting these values. Okay, and I don't know. You could probably make a little table or something. I don't know. Print. Let's cosine. Somebody's going to put me some values. Okay. Oh, it's all... Okay. Cosine of 0 is 1. Okay, that's a good one. Cosine of 60. I don't know what that is in radians. Well, okay, it's about 1, right? Because it's 2 pi, so 6 point something. If you take 1, it should be kind of close to 0. Let's do it that way. Cos of 1 is going to be 0.1. I'm making that up. .54, okay. I mean, I don't think... I'm not going to worry about exact. Okay, whoops. Let's try this one. Print exp. Well, exp is e to the 1, right? Is that 2.17? Something like that. 2.71, okay. And I think this would be improved with some formatting. think this will be 100,000. Int of 1.99. Well, let's make it 41. Len is really not a numeric function. Log of 2.71 should be approximately 1. We know it won't be exact. Oh, random. Interesting. We'll come back on that one. Okay. Sine of minus 41 is minus 1. Signum, I should say, since we also have sine. I forget. Is sine of 0 2 pi? Let's try it this way. Table of sine values, yes. Sine of 0 is 0. Sine of 90, which is pi over 2. Sine of 1 is 0.84, okay. Sine of 100 is minus 0.5, give or take. Oh, that's degrees. Sine of 0, sine of pi over 2 is approximately 1. So 3.14 is 1.57. Should be 1. 1.5. Just a guess. Okay. Should have copied that. Let's see if we print square root of 64, we certainly expect 8. And tangent. Tangent of pi. I have no idea. Let's say 8. Okay. We'll take approximations that sound like they're, plausible. Okay. 0.996 log. Yeah, that's pretty close to 1. Okay. 1.00 is not equal. That seems a little unlikely, doesn't it? So it did not come out as an integer. So it must be just like 0.9994, you know, whatever. Let's do 5.6. Tangent. Um, um, how about something that says, let's find the other related functions? Yeah. Tangent 90 degrees. Infinity. Okay, we don't want to do that. Tangent of 0 is 0. Tangent of 45 degrees. Tangent of pi is 180 is approximately 0. Okay, that's plausible enough. All right, let's see what we got. One failure. Good old sine. Okay, yeah, I'll take that. Okay, and then let's func test random numbers. And I'm just going to do, I don't know, I don't even know how to write a for loop in, well, let's do this. 1 to 1,000 for each. Assert true. We want to say value is greater or equal to 0 and value less than 1, where value value equals, well, rand is supposed to ignore its argument in this version. I really just want to evaluate that function. I guess I'm gonna have to write a little bit of code here. Let's go steal from our helper method here. Interesting. We're gonna have to do a bit of work. I don't know. Maybe I'm not testing this at the right level. Print a random number, capture the output, let value equal output dot trim. No, come on, there's got to be a string function. Remove all. No. Trimming characters in. Adding percent encoding, not what we want. So drop last. And we're going to convert that to a float. Is that plausible? Okay. We run our program. We get the output. We convert it back to float, and we make sure the value is correct. We don't really care what the number is. And that should convert. Okay. Let's just print them once just to make sure. Just expect to see a bunch of random digits. Yeah. Okay. All in range. Good. All right. We've gone for a while. Let's go ahead and take a break, like a 3-minute break. I think at this point we've done all the functions we've got defined here except for len, which is more of a string function. The ones that are fn to n, number to numbers, we've done them all. So, yeah, let's run all tests and check that in first. Okay, test all predefined number to number. And we also fix printing bug where floating point. Where's 2 integers? Okay. Should have checked that separately, but I didn't. All right, so see in about 3 minutes, we'll pick up and work on these string functions. Hi, and welcome back. All right, let's tackle something similar for these non-numeric functions, these string-based functions. Okay. And I don't know, maybe we'll get those tab and pause and those things. All right, test string system functions. They may be more complicated. Let's see. ASC, that converts the first letter of a string to a character, I believe. Integer value, yeah. And a 1-character string of the equivalent to the ASCII value. Okay, well, len is easy. Len of A, B, C, D, E. Should be 5. Okay, and then ASC of TAD. First character is D, so that's 66, 67, 68, I believe. Okay. Are we doing that right? ASC returns the ASCII value. I assume that's the numeric value of the first character in a string. Okay, and this should fail because we don't even have the function yet. Okay, and we promised that if we parsed it, we would always have a function. All right, ASCII is a value from a string to a number, and it's going to take some work. Okay, and I don't even know. I mean, we have an interesting issue because, well, we haven't really faced up to Swift strings versus ASCII strings in the old BASIC. even even there, like, I don't know, is there an ASC function here? The original BASIC documentation is very kind of, it's all over the place. I don't know if you saw the image go by, but they tell you how to use a teletype. Okay, expressions, numbers, variables. I think they might not have any functions for string stuff. Okay, 39. I think you might have strings like this to print, but I think maybe these. Okay, there's int. Somewhere they should list all these, right? Talks about go sub. Okay, let's check the appendices. I gotta decide if I'm gonna do the matrix stuff. I don't know. Limitations, yeah. Yeah, I would say those are not in that original one. I don't see anything. Unfortunately, this one's not searchable. And in 1964, string stuff was not as common. I don't know if you ever saw the original Fortran had they called their strings Hollerith constants, and you would tell it like how many characters are in the string, and like 17H followed by the 17 characters in your string. Putting it in quotes and not worrying about it, not counting it, was kind of a innovation at one point. Yeah, I saw a bunch of numeric functions. Here's the teletype stuff. So I don't think those functions existed. Okay, let me look in. This is Commodore 64, so it's a little later. The OSI 8K, I think, is late 70s, early 80s maybe. This one's maybe, I don't know, 80, sometime in the 80s with Commodore 64. Let's find $sign. Okay, lots of those. Subroutines. I mean, you can tell the size of the manual even gives you some reflection. 491 pages, including a schematic diagram of the computer it runs on. Quick reference card. Let's see if that covers these functions. Yeah. Want to build your own? Go ahead. Okay. It's a little spaces, cursor position. Okay. Dim, len, string dollar, val dollar, a val string, char dollar, ASCII, left, right, mid. Okay, these two basics use the same functions for these strings, so that's something. All right, let's see what we got to do. All right, so given a string, I think we're going to make the assumption that your strings contain ASCII characters. So maybe we'll convert to UTF-8 and see. I don't know enough. I don't do this stuff in Swift too much. Partly the model. So the model has gotten so complicated because you've got the multi-byte Unicode characters and stuff like that. And there's a distinction between what byte are you at versus what character are you at. Because, you know, if you have smiley faces, say, that take 2 or 3 bytes, you know, and you ask for the next character, you get the smiley face. And if you ask for the next byte, you get the first byte of the smiley face. 2 different things. You may want to track either one. Swift string site developer.apple.com. Yeah, Unicode. Okay, so can I get to UTF? Okay. Yeah, so I can ask for UTF-8, and I believe if my string is plain old ASCII, then UTF-8 will be correct for it. Okay, so if I take, let's see, what will we do? Okay, this one maybe is more complicated. Let's test ASC function. Okay, I will take this one as my starting point. Okay, but I'm going to take the string $0.UTF-8 sub 0, and what is that returning me? It's an array of numbers, it looks like. So I will convert that back to a float. Of that. Okay. Cannot convert int to expected type index. Okay, this is the kind of stuff. Let's do dot first. Ha. Cannot value of optional type string element must be unwrapped to a value of type element. Is that gonna do it? Okay, so I will take the string, look at its bytes, take the first one, and convert it back to float, my numeric, and I should pass. Okay, but let's take the corner case, and I'm gonna, well, what happens if we give it an empty string, right? I don't know the answer. Let's see, maybe we can tell from here. First character. I mean, I could return 0. Wouldn't be horribly far off. We're looking for ASC. Okay. If there are no characters, I get an illegal quantity error. Get and just read CHR 0 is a null string. Okay. This one, that's the only explanation you got. You know, I've been thinking more. We have a few places where you get errors. There's only a handful, but what I'm realizing is maybe the value type should produce an explicit error type. And think it's going to have a string and it just prints it. Maybe. I don't want to get too far afield on this. Well, what did its documentation said? It was illegal quantity. Can I even? Okay. I mean, what I'm expecting here is illegal quantity, according to the thing there, and not even a space here. Okay. That's gonna fail for sure. Okay. And empty string. Oh, the print out. Okay. So the weird thing is, if I'm not returning, I'm supposed to return a numeric. You know, I think I'm gonna violate the spec a little bit here. If $0.count equals 0, return 0. Let's just expect a 0. Oh, I gotta have the word return here now. Okay. Yeah, that's a little bit of a violation. Let's add it to the to-do. See if we want to come back to that at some point. What should ask do if given an empty string? Okay, so we've documented what we're doing. I don't know. I've got to return a number here because that's the type of fs2n enforces that. We want to just pass in a standard function and get a result. The difference is, I mean, this function is a closure. It's a wrapped up function ready to apply to somebody. We could maybe let it do a throw and then capture that at the call site and do something about it. But I think we'll let it go. Okay. Let's keep going. Okay. CHR dollar given returns a one character string given the ASCII value. All right. So, and this may be too hard too. We'll see. CHR dollar. So dollar means it returns a character. Well, let's see. We know 42 is asterisk, right? The meaning of life. Okay, and we expect an asterisk. Oh, I should probably make sure this works. Okay, we don't have the CHR dollar function. Function int to string of that. Okay, and let's just return wrong. We're ignoring any values. And a comma after the function. Okay. Well, let me just run this one, make sure we did not mess up the previous test before I go too far. Yes, apparently we did. empty string is not equal to 0. What? The ASCII value, if the count, if the function, I guess if the argument, the string we're doing that on, is empty, returns 0, that should come up true, and we get a 0 back. All right, let's check the other one too. I know, 2 failing tests. Okay, you get wrong instead of star, good enough. All right, this one though, like ASC has to return something. And when we say return 0, then we should print whatever it returns. And we know it worked here. Okay, so let's find function dot apply. Not in here. Apply. Okay, let's break here. We'll skip this one. Whoa. How is that only called once? String to add. Okay. Let's continue. Okay. So ASC gets called. Where is it? I need a function string. Okay. It should get applied, and yet does not. What is going on? Does our string parser not? Let's look. I want to know how we handle strings. Do we handle strings? We do, because we're doing this one. Index substring. Okay. Next. Case quote return string. Okay, we skip over the quote. While we don't have a quote, we append to it. And if we're at the new line, then there's some sort of error. Otherwise, we must be a double quote. So we return. I don't understand why we're not calling that function, though. I mean, that looks like if you came in, you skip over the body starts empty. The program subindex would equal quote right away, so we wouldn't do the loop. We'd skip over the second quote and return a string with an empty string. Let's see, where can we check? Let's look at check program results. Interpreter program. Yeah, let's break there. A lot of tests. Okay, I'll run that again. Oh, that's check program results. Okay. We will skip forward. And the function is string to float. Okay, that much is right. And then operand is string data. Okay, so we'll move forward. Check program results. Okay, let's move forward from there. Okay. Output equals interpreter.run. Let's step in. Let's break here. Okay, and let's look at parse. Skip. Okay, that's saying, well, that's why it's doing nothing, because skip says do nothing. I think, again, I've shortcutted an error kind of thing, and skip is not the right behavior for us. We really want to make an error case. So our parser failed. Let's see line. Make sure it's what we expect. Print. I hope that's okay. Thank you. Not very helpful. Well, this little trick, I can re-execute that, I think. Let's step into. Okay. Case line. Skip. No, it didn't let me do that. Okay. Well, let's re-execute. Skip forward. Okay, let's see line. Okay. Skip forward. Okay, check program results. This one. Now we'll step in. Oh, I guess we can just step. Okay, let's go into the parser. Okay, line. Starts with an integer, that should be fine. Next token. Okay, parse a statement. Should be a print. Go in. Our token is into blind. Nope. Okay. Let's what did we call it? Program? All right, I want to go down to factor. Get through all these precedence levels. Factor, okay. Let's print the token. ASC. predefined. Okay. Predefined. Okay, so let's go in here. And let's break here. Okay. Print the token. I guess I can let this thing tell me. Token is predefined. Okay, good. Step over. Operand types, result type. Okay. Should be a left parend and expression. Number. And this is blowing up. Okay. I'm really not clear. I don't know how much time to spend debugging it and just write a test to the next level down. But I don't know if I'm getting my string in there. I think I'm too far past. Is parse already skip? Yeah. Okay. Well, let's take this down a level to the parser. Check parser. Okay, check parsing. 10 parent expression. I can check expression. Excuse me. Let's find a predefined. Okay. Maybe, no. Well, there's one that passes a string, so expression, and the string we want is CHR dollar empty string this that. And the expected sorry, let's find a check expression and make sure I'm doing this right. One less than two expression dot make. Okay. All right, the expected is Well, it's a predefined. This string is CHR dollar. The expression is string. With an empty string. And the type of the predefined function is dot function takes a string. No, it takes a. Wait, what am I on? ASC. Okay. ASC takes a string. Produces a number. That should be that string. Is that right? CHR dollar takes a string and produces a number, which is the character. Okay. Extraneous argument label. Okay. So if I take CHR dollar of empty string, I should get a predefined CHR dollar expression dot string. I don't think I need expression there. A string of that, and the type's function string to number. All right. Try that test. Let's turn off all these breakpoints. I'll just clean them all off. Okay, continue. Test failed. Expected start of expression is not equal to empty string. Okay, so we did not pass expected start of expression. And that's a parser. And it should have found a string. Okay, let's. I guess we're going to call factor twice in this. Should say CHR dollar. Okay. And we'll continue. Now this one I think should be the string. Error, unterminated string. CHR dollar, quote, quote, right paren. Okay, we're going to go another level deeper. Maybe our Lexer is not able to handle that empty string. String knows its contents. Well, let's make sure. Oh. No. That. Okay, should be the string empty. If you give it a quote and a quote, it should not come back unterminated string constant. That's one thing we know. Yeah, you didn't really run that, did you? Okay. Okay. Unterminated string. So even though we looked at this code, it looked fine to me. Clearly it's not fine. There's string. Let's get it in there. All right. Subindex. Let's break here. All right. Check string. Okay. Let's print program subindex. Should be a quote because we just got in here. We'll step over and program subindex. Should be, oh. What the heck? A new line. This is our normalizer is doing something wrong. Oh, goodness. All right. The normalizer. Maybe split. I bet you split doesn't handle the case of 2 in a row. Oh my goodness. I almost, yeah, I don't know. Let's go look up split. I think there's a flag to say you want omitting empty sequences. If false, an empty sequence is returned for each compare. If true, only non-empty sequences. Okay. We need that to be false. Wait, why is it omitting? If it's true, non-empty subsequences. Okay, we do want false. That is a real hole in our testing, I will say. Okay, we do want empty subsequences back. Okay, let's try this again. I hate that. Okay. Let's continue. Okay. Lexer test. Okay, then we had a parser test. This should be passing now. Continue. No, still not. Okay. Well, that's where we'll break. Parser tests. Check expression. $, quote, quote, right paren. Okay, I think that seems all right. Type mismatch. Oh, that's different. Okay, so we're failing a type check somewhere. $. Oh, where's our definition in the Lexer? $. is wrong. It's not type in. Wait. Oh, it is N to S. Oh, well, no wonder. Okay, that's actually correct. Where's our interpreter test then? Am I testing the wrong one? Oh, no. We want ASC. We haven't implemented CHR. I'm messed up on ASC. Okay. All right. Well, we definitely caught a Lexer defect. Okay, but this should be ASC of that is predefined function ASC function from string to number. ASC string to number. Okay. We'll just continue. Okay, at some point, at least we're testing the right thing now. Okay, predefined ASC expression string empty string basic type number is not equal to 10 basic expression predefined ask string type function. Oh, maybe I've got my type wrong. Let's see what predefined. Well, I would have said this. Predefined. I mean, this is what this constant is for. Type N to S. Oh, I need ASC, S to N. Okay. It has type number. Is that the result type of a predefined? Okay, predefined is the parse, right? Predefined string expression type. Is that the result type, maybe? Do we have another example? Predefined. Oh, that is the result type. Okay. Okay. It's hard to be super happy. At least maybe this one will work. Yay. Okay. Let's take this one out for a moment and run them all. Okay, so we fix defect in normalizing. It omitted empty strings and then made our checked ASC for empty and non-empty strings. All right, now this one. Len should be good. Char star should be failing. Okay. Failing for the right reason. Yes, we hard-coded wrong. Okay, so we're back to action there. Okay, let's find wrong. Whoops. Okay. Let's take a break first, just 2 or 3 minutes, and then we'll come back and see if we can get these string functions done. Hi, welcome back. Alrighty, so we are looking at the case here. CHR42 should be an asterisk. It's not because we just hard-coded this. So we need to get from a character number to an ASCII string in Swift. That sounds like a good Stack Overflow-y kind of question, doesn't it? Convert. Character number to string in Swift. String the character. Well, that'd be handy. Okay. We've got a number. I'm not totally confident in that, but we'll see. Right. 42.0. Yeah. Okay. Let's find character. It's kind of funny there. We don't have an init. It takes an int. Yeah. Okay, maybe this is Unicode scalar of value. Okay. See if string takes Unicode scalars. No. No exact matches. Type of expression is ambiguous. I guess I gotta say return dot string of all that. We return, oh wait, string to value. Whoops. Expected separator. Okay. I don't want a comma there, that's for sure. All right, is that balanced? Something's wrong. Okay. Let's do it though. $0, let's take these out. Get our parentheses straight, and then we'll get our exclamation point straight. Okay. Value.function should have 2 of these. Okay, so we get a string, character, Unicode scalar, int. It matches. String matches. It's in brace print. Okay. Now Unicode int must be unwrapped. Type string has no member string. Value.function. Oh, I guess we don't need the dot string on here. Okay. Yeah, so like I said, getting characters to strings and all that, it's complicated. Okay. I think this is even byte. No. Okay. Let's hope for an easier one. ASC was a little tricky. These ones with strings, I think, you know, they have a little bit of stuff going on. Gives the leftmost I characters of string X. I think we definitely want to look up that on here. Left. And they at least try to do a little more. Okay. We don't have to make that string length restriction, I don't think. But we want the leftmost characters, so let's do a test here. So check program results. Well, this one's probably complicated enough that it deserves more, huh? Test left function. Left dollar of quote. Let's start with empty. empty 10 should be empty. Missing argument for parameter, insert expecting, yes. Print the left of an empty string. Oh, come on. Quote. And quote, 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 quote. Okay. Let's kind of work our way through them all. Okay, if you ask for more than there are ABC, you get them. If you ask for the first two characters, you'll only get AB. And if you ask for 0 characters, you get an empty string. Okay, so the left of an empty string is always an empty string. The left, if the number is more than the number of characters. If the left is less than the number of characters. And if it's 0. Okay. Function doesn't exist yet. Okay. Left dollar. Function. It's a function of a string number to string with this function and a comma. Okay. You've got a string and a number. Okay, well, the string with $0 dot, and I don't know, is there a left? No. Prefix. Max length. Let's see. Up to the specified maximum length containing the initial elements of the sequence. I think that's pretty good. $1. Cannot convert float to int. Okay. Cannot convert. Okay. Oh, still got a syntax error, huh? Need an exclamation? No. Oh, yeah. Okay. I'll get all these domains right. Only 4 failures. Okay. Empty string is not equal to double quotes. Quadruple quotes. Oh. I am only expecting, yeah. wait a minute. I think I'm expecting a new line. Empty string is not equal to that. I don't expect to print the quotes on an empty string. So I do expect that. Okay, so take these quotes out. I thought I would have a new line in there, but maybe not. Okay, let's try again. Okay, empty string is not equal to ABC. Print left $10. Empty is not equal to AB, so the prefix thing doesn't seem to be prefixing. And I really thought I'd get a new line here. All right. Well, if this one failed and this one worked, then I'd say my prefix is doing the right thing, but I'm a little puzzled here. Let's see what this thing says again. Make sure it's the function we want. Okay. Returns a subsequence containing the initial element until predicate returns false. Predicate, okay. Returns, oh, max length. Okay, returns a subsequence up to the maximum length. Prefix of 2 is 1, 2. Prefix of 10 is 1, 2, 3, 4, 5. Okay, that seems like what we want. Must be greater than or equal to 0. Okay. At most, it seems right to me. Sorry. Okay, back to interpreter. We're taking the string we're given, that's the $0, taking the prefix by the int we're given, $1, and then we return a string, and that seems okay. All right, let's break. Let's find that apply and break there. Okay. And this one's passing, so I'm just going to comment this one out for a moment. We'll start with the one that's failing. And actually, I think a more expected result, I think this is a better order. Here's the sort of base normal case. Here's the case of 0. Here's the case of more than the number. Okay. And I will run. Without getting there. Okay. What's going on? Left dollar, left dollar. Let's make sure that's in here and in the lexer. I thought I put everything left dollar, predefined left dollar, SN to S. Okay. Um, let's see if we get here. I guess we don't if we didn't get to the other one. Okay. We don't handle more than one argument. Okay. Yeah. I just remembered that. Okay. Let's save that one. Okay. Test predefined numeric functions. Okay, we've done that. My list is getting longer. Okay. This one, predefining string functions. Remaining, well, it's really, let's do single argument predefined string functions and then multi-argument. Okay. We have a little bit of support for it, but not full support. So the type system handles it and it expects lists of arguments, but we don't actually parse them. All right. Well, that lets us off the hook for left, right, and mid. Len of x is the string and bytes. We already do that one. str dollar is a character representation of the numeric thing s. Okay, that sounds easy. Let's test that. And I think if we give it a hard one, print, what was the name again? str dollar. str dollar of minus 21. We're expecting minus 21, new line. Okay, and this should fail. We'll just continue. Fatal error. Okay, that suggests we're missing the function name here somewhere, which I guess we are, str dollar. And it is a numeric to string of, and we're going to have to define it. Okay. And a comma. Numeric to string. Okay, and we're just, I think that's just string of $0. they get? 3.1. I would actually say this is our format should apply. Okay. We got a number. Let's return format of number. Format of that number. Format of the $0 is going to be a let's find format. I think he's a pure function of, oh no, he's not. Let's extract this. File private format, and I'm going to make this a static function. Static function format. It takes a float, returns a string, and I think we can maybe use that up here. Cannot use instance member. I don't feel like that's got the right one. Return format of number. Yeah. Oh, still fails, huh? Oh. Okay, let's pull it out further. I'll just leave this as a floating one. Again, I'm going to build, see if I can get this thing. Can I use member instance? Let's call it basic format. Try again. All right, and then the last one, val. Okay. Let's add that down here. Results. Val of 21 should be 21 new line. And then, well, let's make this, it's the number, so, maybe junk. I don't know what we'll do there. I'm not quite sure what, okay, function's not present. This is function string to number. And let's return float of string. Oh no, I'm going to say else 0. Okay. I guess. Oh yeah, we certainly were expecting 21.25 at least. This thing where we've said it's going to default to 6 digits, it's bubbling in a little bit much, but we'll make it go. Is what we'll do for now. Okay, well, that's a good place to stop. So what we've done is we got the single argument functions all done. So let's claim those. And we'll commit that. Okay, so we've got our single argument functions all defined. We need to pick up with the multi-argument ones, and we'll do that next time. So next time is tomorrow morning, 10 a.m. to 12:30 noon, or just past noon Eastern time, 3 to 5:30 UTC, and it's 9 to 11:30 for me in Central time. But we'll pick up there with the multi-argument functions. I hope we finish that tomorrow. And start on the arrays. I had hoped to start the arrays today, but I'd forgotten we didn't do multi-arguments. But we only have 3 of them, and like I said, we got a little support already, so I don't think it'll be too bad. Thanks for joining me, and I hope I catch you again in the future. Take care. Bye-bye.